Hey guys, welcome back to Consistent Code. So today's problem of the day is median in a row-wise sorted matrix. So basically what this question is, we have been given a matrix. So suppose this is the matrix which we have been given, and these are its rows and these are its columns. So what we need to find, its median. Okay, so what is a median basically? So if I just put all of these elements in a sorted array, then it should be like 1 2 3 3, then it should be a 5 6 6 9 9. So when I put all these elements in a sorted array, then the middle element will be the median. So how to find this median in this? So one of the basic brute force approach would be that only, that you create an array and store all the elements in this array and just return the middle element of this sorted array, and that will be the answer. But the time complexity in this brute force approach will be O of rows into columns. So that's not very efficient approach. So how can we optimize this? For optimization, we can look at some observation that when we are considering this median, so this is our median, then what is the property of median? That if the total size is r into c, so, and since it has been given in the question that r into c is odd, so for a median, in the left side of this median we should be having r into c by 2 elements, and here also we should be having r into c by 2 elements. So if I see, then I can say that if I include this median element and the left elements, then I am having r into c by 2 plus 1 elements. Okay, so that's what we can do. And we know that the rows have been sorted, so whenever we see sorted, we should try to use binary search. So in this problem also, we can just optimize this to O of r into log c using binary search. Now how to do that? Let's see that. So what we can do, we can just first of all take the minimum and maximum value. So if I just consider these elements in my rows, I will get the minimum of these values as the minimum element for the entire matrix, and so this will be the minimum element of entire matrix, and this, among these, the maximum of these will be the maximum element of entire matrix. So first I can just calculate the minimum and the maximum values, and now what I need to do, I can just imply a binary search over it. How we can do that? Suppose I'm having minimum as 1 and maximum as 9. Here, as you can see, this and this. So what I will do, I will just see the middle element, that will be 5. So I will just assume that this is my median. So now I just need to check that property, that if it is a median, then in its left and its right, the elements should be r into c by 2. Okay, so if, how can I know how many elements are in the left? So I can just create a variable and take upper bound of this 5 in every row, for each row. So what I can do, I will take upper bound of 5, so I will get in the first row as 3. I will add this 3 in my answer because these elements, so I'm including this m also. So basically what I'm doing, I'm considering this 5 as a median, and now I'm checking how many numbers are there which are less than or equal to this median in the entire matrix. Okay, and for finding that, we are using binary search, right? So by binary search, we can just take the upper bound of this median for every row, and the sum of that will be our total numbers on its left side. Okay, so this is what we are gonna do. So for 5, in the first row, when we are at this place, for 5 we will get 3. Now at the second row, the upper bound of 5 will be this 6. So we get the number of elements here as 1. Here the upper bound for 5 will be again 6, so the elements here is also 1. So in for every row we just calculated the number of elements smaller than or equal to median in log of log n complexity, that is log of columns. And for we did it for each row, so time complexity becomes O of row into log of column for calculating the number of elements on the left, or small the number of elements that are smaller or equal to median. Okay, now when we get this number, the number of elements smaller or equal to median, so how to verify that this our assumption is right, that it is a median? And that's very simple. As we have already seen that if it is a median, then the number of elements on its left and including the median will be r into c by 2 plus 1. So if our answer, that the sum we calculated, is equal to this, then this is our median. Otherwise, if this is less than sum, then uh, what we can do, that means our sum is greater than our desired. So in this case, what we will do, when it is less than sum, we can just make our maximum value to be equals to mid, and if it is greater than sum, in this case we will make our min equals to mid plus 1. So this will apply the binary search, and this will solve our problem. So now let me just walk you through the code. First, we found the minimum and maximum values for the entire matrix using in O of R complexity, because we just need to iterate from 1 to 3 for minimum and 5, 9 and 9 for maximum. Right, we found the minimum and maximum values. Now we will see the desired position of our median, that will be r into c by 2 plus 1. And now we are just applying binary search for every row. So we will just assume our median as this element mid, and now we will check how many elements are there on its left and the mid including that number itself. So we check this for every row and calculate the sum as a variable left. So if left is less than our desired position of median, that means we need to make our minimum, we have chosen the median such that it is less than the actual median. So we will take minimum as mid plus 1, so we can get in the next iteration we can get the median increased. Otherwise we can just consider our max as our mid, because otherwise we have assumed the median to be greater than actual median, and we will reduce it. And finally our mn will be the actual median. So now let's submit this code. And we have solved this problem successfully, and I'll see you tomorrow with the next problem of the day. Make sure to hit the like button and subscribe to the channel if you like the explanation.